Good afternoon. So first, we have a slight revision to our talk title. It's going to be Python for Open Data Lovers, because we love open data. And that's going to be a significant emphasis in our talk. So our big goal today is to use data to build a story about how and where DC city agencies are spending their money. And as part of that process, we're going to show you several different Python libraries and Python-based tools and other open source tools for analysis. But first, we want to tell you a little bit about us. So, Jackie.
So my name is Jackie. During the day, I work for CACI at the Library of Congress. And at night, that was me having fun at PyCon with Zane. At night, I'm doing some graduate studies at George Mason, and I help run Django District. This was our last meetup. It's my little plug to come to DjangoCon DC, because that's how we do Django in DC. So I think it's you. So yeah, that's me.
So I'm a geographer based in Philadelphia. I make maps and analyze data for a living, mostly for non-profit clients. This is one particular map where I looked at poverty in Philadelphia and locations of childcare facilities. I wrangle open data all the time in its many forms, and I use lots of different tools to do this, and I'm kind of agnostic about that. I use mostly open source, sometimes Python, but not always. I also organize Intro to Python workshops through the Philadelphia Python Users Group, and we really relied a lot on the Boston Python workshop folks and the PyLadies to help us get started, and it's really nice that several of our workshop instructors and students are here at PyCon thanks to PyLadies and the PSF. So that's something that I'm really proud of. So where are we going today? First, we're going to give you a little bit of an overview of the open data movement, these enormous amounts of data that have been released by cities, counties, states, the federal government, in formats that are, for the most part, consumable by ordinary people like us. And then we're going to describe one particular data set from the DC catalog that Jackie and I found interesting, and this data set will be the thread that pulls us through our talk. We're going to talk specifically about some tools that can help you explore open data, and we're going to start with a tool that is really simple and really powerful. We like to call it the Data Swiss Army Knife, and I believe others have called it that before. And then we'll talk a little bit about more complex Python-based tools that will help us look at patterns in the data and try to make meaning. And at the end of the talk, we're going to discuss some steps for how you might go from a data analysis to actually building a story that you could share with users and readers in many different forms. Okay, so I'm not going to provide a full overview of all open data initiatives, but let's suffice it to say that there's been an explosion of data in the last few years in this civic sphere. And it's sort of a party out there of liberating data, connecting data, gold starring data, tweeting about data, blogging about data, hacking on data if you read the language on some of these sites. And these are just some examples of different city data portals. Some cities do it better than others, but there's been a lot of exciting development in just the past couple of years. And so a lot of the sites organize their offerings in many different ways by file type, but a standard way of presenting it to lay people is data from A to Z. And so I've pulled a smattering of selections from all these different city data sites. And when I see this list, I see potential stories. And because I'm a geographer, I look at this list and I think about maps. And in fact, many of the data sets on this list have been in the news. For example, assembly member expenses from the London data store. That was in the news. People were spending money on things they shouldn't have, and I think some of them actually got fired when The Guardian started writing about it. In Philly, the transit data has become quite a thing, and there's a lot of momentum around building mobile apps for SEPTA, our regional transit authority. I've spent a lot of time in my past job looking at political districts and measuring compactness and trying to come up with measures for gerrymandering. All of that is open data. I have some colleagues who look at violent crime incidents in any number of cities. So that last data set, I couldn't come up with an X, so I gave you an extra R. Real-time parking availability and pricing. It's actually an API from the San Francisco data, and that is, I think, one of the most amazing creations from open data, and every city should have something like that. So our focus today is on the DC data catalog, and Jackie and I decided to pull data sets from this site to be the focus of our presentation today. This particular site was launched during the Adrian Fenty administration, and the city got a lot of kudos for doing it right. And one open data advocate said it wasn't just the breadth of data on the site, it was that DC seemed to have integrated the principles of open data into its very DNA. So the offerings here are really extensive and pretty impressive. It might not be the easiest site to navigate, but there's a tremendous amount of data here. Just as a side note, when Vince Gray came into office, he closed off a portion of the city data catalog that was at one time readily available. And there's a great blog post about this from the Open Knowledge Foundation, if you're interested in reading it. It basically had to do with data on registered businesses in the city. So let's take a little bit of a look at our study area here, just to orient you. Most of you probably know that DC is really nestled in between Maryland and Virginia. So any look at the business landscape in DC is going to have to take these two other states into account. And so there are some geographic constraints here on the pattern of businesses within the city. There are also some tax constraints and permit constraints that affect how businesses spread in the city as well. So a few of the questions that we were really interested in were, what are DC agencies spending their money on? How much are they spending? What are the relationships between these businesses and city agencies? And where are these businesses located? And so to answer some of these questions, we pulled down 7 years' worth of purchase order data from the city, which sounds kind of crazy. It was all in CSV format. But we wanted to get a look at some of this spending over a long period of time, and the Open Data site made that possible for us. And so, of course, when you pull data from a site in CVS format, you get this, if you're looking at it in a text file, which is kind of daunting for some people who are perhaps new to Open Data or Python. But lucky for us, this is our data Swiss Army knife. It's called CSV Kit. It's an amazing set of Python utilities for working with comma-delimited files. And it was developed by some journalists at the Chicago Tribune. The documentation is excellent. And there are a number of tutorials out there. And for people who are fairly new to coding or command line, it's a really fantastic introduction to working at the command line. And it's super, super easy to install. So one of the first things we did with CSV Kit when we pulled down these comma-delimited files of purchase order data was just to take a quick look at what we had. And this is one way to examine some of the headings. So we have purchase order numbers, agency names, Descriptions, the money, of course, date, and suppliers. You can also cut some of the data and get some basic summary statistics. So here we're summarizing number of agencies, number of suppliers, and the groups within both of those camps that have had the most transactions, and this is just 2011. So you can also, if you want to look for something in the data, you can use a little bit of regular expressions with CSVKit. In this particular case, we are focusing on how many different transactions there were with the Maya Angelou Charter School. And so here was just a quick look at the top transactions, so where a lot of the money was going, transaction by transaction. And this alone could be the basis for any number of stories. A huge amount of money to construction companies, a lot of money spent on healthcare in prisons, money spent in schools. We found this alone very interesting. Moving beyond that first look at the data, we decided to start with some more complex pattern analysis.
So the International Network for Social Network Analysis describes social network analysis on their website as social network analysis is focused on uncovering the pattern of people's interaction. You know, it's really hard to describe social network analysis in a few minutes, so I want to try to do this by example. So this was a social network analysis project on congressional votes that I had done a year ago or something. So this is looking at how individuals in Congress vote together in the same way. So if they both approve, they get a link. If they both disapprove, they get a link. If they're absent, they're not counted. So this was the 99th House. There was a little cross-pollination, but we're going to go ahead and fast forward to the 107th, where there is none. And so what I want you to notice in these is that whoever's in majority tends to have a closer clustering than the party that is not in majority. And we're going to go through a couple more years. So again, the Republicans have the majority. Republicans have the majority. Democrats have the majority. And Democrats have the majority, but there's still a lot of back and forth, so the Republicans still have a pretty tight clustering there. So this was just to try to show you guys an example outside of the context of social network analysis, how a lot of people might think about it, like with respect to Twitter or Facebook, and those kinds of contexts directly relating to social networks. Okay, so we took our CSV and turned it into a network. This is really stripped down code. There are other steps to this, but I just wanted to give you an idea of what this involves. It's really simple. You import network X, create a graph, create a node edge list, loop over your CSV file for your to add your nodes and possible edges, and then loop over your possible your node and edge list twice to compare it against itself, and then add your edges to the graph. So before we get to more fun stuff, this is describing social network analysis. I can't just pass over it without saying something about centrality. So there's different ways to measure centrality. There's degree, closeness, betweenness, and PageRank. Because I'm not going to go into great detail about this, what I suggest is there are some resources at the end of this talk that you get a book and read more. Because what I'm showing today is just going to make you dangerous, very dangerous. So running centrality metrics against the network. We have a couple of obvious winners up top. And looking at these people, Digidocs Document Managers offers software that generates loan documents for electronic delivery. Now, before I continue, let me explain what this means. So we had some of the raw pools of data, which you just query a data set and you can count transactions or count money or count sort of aggregated results. This is showing overlap between agencies. So there are a lot of agencies in DC who use Digidocs Inc. Iron Mountain provides information management services that help organizations lower costs, risks, and inefficiencies of managing their physical and digital data. So a lot of people, a lot of different agencies pay money to lower inefficiencies. So MVS Inc. is a consulting, I think technology, yes. MDM Office, office supplies. There were quite a few office supplies on the list. I just want to say I think this is the only one of the ones that I saw that also offers coffee services. Capital services and supplies. Just general office solutions. And the bottom two are both, I just want to point out, located in, or the bottom three are all located in Washington, D.C. I didn't include descriptions of the U.S. Postal Service and Dell Computer Corporation because I figured most of you guys would know what those were. So, visualizing the network. After you take a look at centrality, what we want to do is try to see what this network looks like. So you run it you run the graph through a Spring layout, which sort of pulls nodes that are alike together. And then plotting the figure, you can change the figure size. I did 15 by 15 for the purpose of this presentation. And then you're drawing the nodes. And we'll show you what the graph looks like. So it looks like a hairball, which a lot of these graphs do, and it doesn't bring a lot of meaning. So what we're going to do is trim some nodes. And what this is doing is basically looking at the degree, which was one of the centrality metrics. So degree is how many nodes are connected to an individual node, and basically removing the weak links. And so this is the original degree distribution. It's kind of power lawish. Well, definitely power lawish, except for this random spike, which I have not been able to explain. So that's part of the more research. So this is after trimming down some nodes, trimming a little more. And then we have the center of the network, which is a little bit easier to see what's going on. So then adding labels to the network can help you identify who is located where in the network. This is really hard to show without having a larger screen. But I will show you a bit. Oops. There we go. So then you can see where your nodes are located. Further things you could do is also, and I didn't include this, but you could size nodes by money spent and sort of see juxtaposition of where the nodes are. But now I'm going to turn it over to Dana for mapping.
So what Jack Lee actually just showed you was a special kind of map. And They weren't maps in the traditional sense, but basically they were maps of relationships that are not inherently spatial. And the jargon here is the spatialization of aspatial data, but I promise I won't say that again. So now we're going to talk a little bit about how we might examine some of these patterns in space. So first, anyone here who's worked with spatial data knows that it's special and not always in a magical, wonderful kind of way. It can be a real pain to work with. But the cool part, of course, is that it is mappable. One of the challenges, on the other hand, is that you have to deal with things like spatial references and projections, and that can be really difficult. And if you screw that up, not only can your data look really funny, but any kind of underlying analysis, distance or density can be really, really far off. Just an important thing to keep in mind with spatial data is this concept of things that are closer together are more alike than things that are farther apart. And that's an oversimplification of Tobler's first law of geography, but it's really a good thing to keep in mind when you're trying to understand how points or polygons in space interact and how you might describe in a mathematical way that particular interaction. So there are lots of different types of spatial analysis. Like a lot of other types of data analysis, you're basically trying to derive meaning from large data sets. One of my favorite ways of looking at spatial analysis is ESDA, exploratory spatial analysis, where you're running a lot of tests to explore local and global patterns in the data. And it's a great way to get a sense of what you have and what you don't know. And it can be a fantastic way to help you ask better questions of your data. Spatial statistics is a type of spatial analysis, and then more complex mathematical predictive modeling. We won't get into that today. And there are a lot of different techniques that you can use. We're looking at point data here, so there are many ways that you can look at those spatial relationships between points, and also there are techniques that are particular to spatial statistics, different types of spatial regression, for example. So there are many Python-based tools for working with spatial data. I come from a GIS mapping world, so I like using a GIS to explore data. And there are many different kinds. All of them play really nicely with Python. For this particular example, I used a package called QGIS. So let's back up a little bit and come back to our CSV. So how do we get from this to a map? It's not magic, not even close. And one of the most difficult things about preparing data for a map is the cleaning of it, especially if you're going to be doing any geocoding. And so here, this is not at all a Python tool, but I rely heavily on Google Refine for this kind of work. And it's an amazing way to find clusters in your data and correct things en masse. You can also geocode within the Google Refine environment, and that's what I did here. So what do we end up with? Points floating in space with no real context, but you can probably see very roughly the outline of the United States there, the eastern seaboard. So let's add a little context here and project it. So these are all of the businesses that DC agencies purchased from in 2011. And there you can see clustered mostly around major urban areas. Most of the points are in the eastern seaboard, but you can really get just a visual sense of where, what businesses were being solicited. So we'll zoom in a little bit to the DC area where our largest cluster is. Zoom in again to the city proper. And so here I'm showing you in large dark gray points where the actual agencies are, and then the polylines are business revitalization corridors. So one question we might ask, is the city really trying to buy from businesses along these corridors? And that's something that we'd like to look at some point. So there's a really fantastic spatial analysis library in Python called PySal, and it was developed by researchers who are now at Arizona State University. And the Geoda Center has a number of different software tools, some of them built on C++, a lot of them built on Python. And there are modules in PySal for a lot of the different spatial analysis techniques that I talked about earlier in the presentation. It can be a little complicated to install, but it's very powerful. It's great, in particular, for developers who are looking to incorporate some of those spatial analysis methods in an application. It's pretty good for GIS analysts who want to do some custom scripting, but for the most part, if you're looking for a user-friendly GIS or a user-friendly GUI for this particular set of tools, you might try one of the wrappers that the Geoda team has created for them. And on the horizon, there's going to be quite a bit of PySal integration in these other GIS packages, ArcGIS and QGIS in particular. So this is a schematic of PySal here with all of the different modules and components, and the exploratory spatial data analysis package is perhaps the most well documented and developed. So if we were to continue using this data set to build a possible story, next steps would be to use some of the PySal tools to quantify some of these clusters in the city and the region and the nation, and in particular to examine clustering along networks and those business corridors in particular. And then a step beyond that would be to create really beautiful interactive maps and charts so that users could go in and explore the data on their own.
So, I mean, part of this is about telling stories. It's something both Dana and I like to do. My background is actually in journalism, and I used to work for the Washington Post. So, which stories would we go after? Construction contracts, funding to charter schools, healthcare costs in prisons was actually one that I believe Dana found while looking at the data. Local versus regional versus national purchases. DC has a very odd layout in that originally it was a 10 by 10 square, and then they hacked off what is now basically Arlington because they felt like it wasn't worth anything. And so it's 68 square miles. There's not a lot of room in DC. So local versus regional, regional being Maryland, Virginia, and then national. And then technology services. One of the things while looking at this, what I noticed was that there was, it seemed to be that there was a lot of overlap with hiring consultants and technology services by various agencies in relation to sort of different needs that each of them had. Like a couple of them might have hired a couple of different DBAs or DBA consultants. So looking for overlaps for that where there could be possibly consolidation of services. And lastly, we provided some links to learn more. The SAGE Handbook for Spatial Analysis, Interactive Spatial Data Analysis, Geographic Information Analysis, and PySal. And there's Dana's daughter, who's a geographer in training. and more. The NetworkX tutorial is really great, and NetworkX, they have a pretty responsive mailing list. I found a UCD Dublin summer course that had a lot of great materials. And then I want to recommend a book. I want to say I do have a personal conflict of interest because my professor wrote it. Social Network Analysis for Startups by O'Reilly Media. And I think if you find him, he's sitting in the front row, he'll give you 40% off.
I have coupons.
And questions?
Hi, so you talked about how the DC data set got shut down. I actually lived in DC when that political change happened, and it was a big deal because people kind of suspected that kind of thing would exactly happen. So what, and this is, outside mapping, but as sort of digital citizens, what can we do to help keep open data open? Or who's working on that?
The Open Knowledge Foundation is really a fantastic resource here. They're having a huge summit somewhere in Europe early this summer where a lot of different open data advocates from all over the world are meeting to discuss this sort of thing. I think that the sites are, they're there for people to use. And I think most cities that go to the trouble to create those sites want people to make things with the data. And so I guess what I could really just encourage you to do is to make stuff with the data and keep using it, keep asking for more data to be opened up, and create a need for that, an initiative in your own city around that.
Cool. Thank you.
I also want to add to what Dana said and say that just because a data set is not available online does not mean you can't gain access to it. Sometimes if you're nice and you ask, they'll give it to you. And sometimes they'll give it to you in the format you want. And lots of times they won't. And lots of times they'll say that'll be $1,000. Or
they'll give you a PDF.
Yeah, a PDF. Yeah, they'll give you a PDF. So, it doesn't hurt to ask. Lots of times, too, I've heard of people getting data from the government via web scraping. Be polite, be nice, identify yourself. And it's nice to just ask first. And if that doesn't work, then you can FOIA.
And then they will give you Word documents, which they've done to me in the past. So, sort of following up on getting in touch with people, one thing that I used to run into when I did this a lot was resistance not to, there would be sets of data that were available, but we would still want to talk to the people who were providing that data and knew it best. And they would be really hesitant to talk to us. Like we did one a couple of years ago when everybody was worried about swine flu. We talked to our state health department, we got their weekly reports, we got the CDC's weekly reports, and they came in sort of with this dismissive attitude toward us of, well, you're not epidemiologists, what would you know about presenting this kind of data? What would you know about analyzing this? Have you ever run into that and had any sort of breakthroughs or ways to convince people, yes, we really do know what we're doing and we can, tell compelling stories that won't make you want to tear your hair out?
So I've had experiences with a city-related agency being really reluctant to release data on green space and the turnaround of vacant land because they knew that particular researchers were going to look at the relationship between that green space and crime, and they were a little nervous about how that study might turn out. So that's been my experience with it. It wasn't a concern over the group's ability to analyze the data. It was concern over what the study might reveal.
So I haven't had any experiences where somebody outright sort of denied me data for the sake that they didn't believe I could analyze it or look at it correctly.
Well, they didn't deny us the data. The data was published free to the public. They just didn't really...
Discuss it with you.
Yeah, they didn't want to talk to us. They were afraid that we would screw it up.
Okay, sure. I mean, hello? Okay, sorry. You're gonna run into it. I ran into it. I think we ran into it when I was at the Washington Post and we worked on Top Secret America. No one's going to talk to you, or very little people are going to talk to you. And sometimes, you're trying to add context to sort of what you found. It's hard. Another way to get around it, too, is to try to find professionals or academics in the field that are familiar with the data, maybe not necessarily the authority where the data came from, but someone who could speak to the data and offer some insight.
So my experience trying to track down political data is that most data people like to talk to other data people. And so I would find myself on the phone with these other GIS analysts, often trapped in little offices and city agencies, who were dying to talk to another GIS person. And it was like 45 minutes of therapy on the phone, how no one understood how hard it was for them to deal with spatial data. So maybe it's just a matter of finding the right person to talk to.
You guys called out ArcGIS as one of the tools to work with. Have you done anything with TileMill? Have any experience with that?
So I'm fairly new to it. I played with it some in preparation for this presentation. It didn't make it into the presentation because I'm still new with it. But yeah, I was really amazed with how quickly I could just start getting maps up there and doing more complicated things with them. So I think that if we were to take this to the next step and turn the analysis into a more developed story that we might share, that would be an amazing tool to use to have that interactivity.
Okay. And TileMill. And I'm serving as Adon's voice. He wanted me to ask if you have any experience with D3 and visualizing geodata, and anything that you can share on that.
Actually, yes. I have some recent experience using D3. There's not D3. Yeah, D3 is pretty awesome. New York Times started using it. There's nothing. I'll say that you can kick out maps fast, and you can present stuff fast. But if you're putting stuff on the web, you're going to lose some of the capabilities that you get with PostGIS and GeoDjango. Being able to do spatial analysis, because you're going to write a lot more code, and it's already, you're basically going to rewrite what another service already offers. So, I mean, I would say with D3 and maps, it's fast. I'm in the middle of a project right now using D3 and maps called Election Gauge, which is a comparison of candidates' corpus and tweets, and looking how different regions, the language people use compares to the language of a candidate in different regions. It's in development. New features every week or every other week.
Thanks.
No problem.
One of the really interesting things to do with your social mapping data for the DC contractors would be to combine it with other publicly available social data, such as who's on whose board of directors and who's married to whom, and who used to work for whom. Have you done any of that?
No, but that would definitely could be a definite future story. I mean, also looking at job movements and of individuals who work at agencies. LinkedIn, there's a lot of great information
Yeah.
that you can gather. So yeah, that's definitely a future possibility. Thank you.
So you had one data set that seemed to have two different sets of networks. You had both spatial relationships as well as the network relationships. I was wondering if there was any way that you knew of to integrate a topology or a network to physical spatial map.
Yeah, so the Geoda Center is a great resource for learning more about how that works, and they build tools that would allow you to do that kind of spatial analysis along networks. So I would encourage you to check out their website and the documentation of their various tools that are out there now and that are coming out soon. So there are people doing that kind of work.
Thanks.
Thank you.
Thank you.